When you first enter the room, turn off the HEPA filters. Okay, on the switch. Alright, the first thing you do is to sign in the logbook. So put your name down legibly, the date, the time. We no longer use the liquid nitrogen trap. If you should happen to flash while you're using the tool, make a note of the flash current, the start and end extraction voltages, and then the timeout. So these you will enter at the beginning of your session, at the end of your session. Alright, checking column defaults. This is the cold trap, which we don't use anymore. There's the infrared camera back here, and the monitor need to be turned off. The pico ammeter, off. The EDX detector should be in position 6. It's extracted. The beam monitor aperture is either 2 or 3. The objective aperture is either 2 or 3. The Faraday cup should be out and the switch sent to meter. And finally check that the bias cable is connected. Checking the vacuum defaults. This is the emergency off button. This is the evacuation power status. The turbomolecular pump, water and air pressure should all be green. The objective aperture should be in heat mode with a green light. Then we check the status of the ion pumps. There are 3 ion pumps. So the typical settings are these: ion pump 3, 10 to the minus 6 pascals. Ion pump 2, 5 times 10 to the minus 8 pascals. And ion pump 1, 10 to the minus 8 pascals. Next we go to the chamber vacuum. So SC stands for specimen chamber, and SEC is the specimen exchange chamber. Both should be in high vacuum mode. 2 10 to the minus 1 is the typical default for the specimen exchange chamber. So now check the specimen chamber, and that typical value less than 10 to the minus 1 is good, and then we'll check with the penning gauge, and that should typically be less than 10 to the minus 3. Then you return the switch back to SEC. This panel gives you the valve status. There are only 2 valves on this tool. There's the manual valve, and then there's the automatic gun valve. So the correct colors here are both green, and these should be flashing. Last but not least, this panel allows you to vent the specimen exchange chamber or the specimen chamber. The typical default is the specimen exchange chamber switch is in the right position. Alright, so we run the FESEM application. Log in with your user ID and password. Okay, now we can check the software defaults. The first thing you check is the stage control. We have 3 options. You can use the drop-down menu, so operate stage control, or you can use the icon. If you look in the manual, this is the icon. And Hitachi gave us a 3rd option, which is this button here. So the default should be green, go to home, meaning that the stage is at the exchange position. The lock button should be grayed out. The default sample size should be 15 millimeters, so go ahead and set that. Okay. The speed should be on fast. XYR, Z tilt, and memory drive should be checked. Image navigation should not be checked. X and Y coordinates should be 25 and 25. So this is close enough, 24.998. Physical rotation should be 0. The working distance Z should be 12. The tilt should be 0. Continuous should not be checked. Priority Z should be checked. Okay, so we're done with checking the stage defaults. Now go to the high voltage panel, just right click on it. The default voltage should be 15 kV and the emission current should be 10. Note the flashing button where there is an execute function. We will talk about this later. Next you should check the column setup. Again, you can either go to setup column, or if you prefer the icons, it's your choice. The default should be normal mode. The working distance should be 12. Condenser lens 1, 2 should be checked. Specimen voltage bias should be checked. The condenser 1 lens setting should be 5. The secondary electron detector default is the upper detector. Flash intensity should be 2. And the ABCC link, which is automatic brightness and contrast control, should not be checked. Next, just verify the signal select. So go to setup, signal select, and basically we should all be in secondary electron mode with background and image checked, and of course again upper detector checked. Next we check the signal processing. Move this over. So this is for basically imaging live. You can choose different frame speeds. Of course, if you choose 1, it's very noisy. So the default is 16 and 32. And these are selected over here. We have mathematical signal processing, and gamma and differentials should be off. Gamma is logarithmic compression, and differential is exactly what it sounds like. It actually differentiates the image. Okay, next we check raster rotation, so operate raster rotation, and this should be checked, and this should be 0. Next we go to setup image. There's a number of things here to check. There's a preset magnification function, and it's 2000, 10,000 and 50,000. If you need to use them, they're here. So there you go, 2000, 10,000, 20,000. But we generally don't use it. The automatic brightness and contrast control should be 3 and 3. The adjust beam monitor, which is this little panel here, should be checked. The capture resolution, when you actually come to capture images, should be 1280 by 960. And then here you can set the capture speeds for frame average, and the default 16 and 32. And for the conventional slow scan, this should actually be 40. Auto increment should be checked, but capture memory overwrite should not be checked. Otherwise, once you've acquired your images and you forget to save them, they will be overwritten. Screen mode, standard. Next we check the data display, and in fact the date should be checked, the time should be checked, and the signal name should be checked, along with the magnification micro marker. So these are the things at the bottom of the image which appear on anything you capture. Last but not least, we check the image pseudo color, and this should be turned off. You can turn it on. You can get a color bar,
However, you can image in color, but you can only capture in grayscale, so for the most part we do not use this, so that should be off. And those are the software defaults you need to check before you fire up the high voltage.
Okay, assembling the sample holder. You'll need the dovetail base assembly, the locking washer, a threaded post, and the height measuring jig. Today we're going to use the Hitachi high-res standard as the sample. So the sample is already mounted. So take the threaded post and feed it up through the washer. Then take the dovetail assembly, ensuring that the dovetail is on the bottom. And then you can tighten the lock washer a little. Now we can mount the sample on the top thread. Make sure it's on tight. Now we can check the height on the jig, and we see it's low. So unlock the washer a little and then just unwind the sample. Tighten it a little. Check the height. Just needs a little more. And that's about there. This will ensure that the sample, when loaded in the microscope, will be at the 12mm working distance, which is the default. Loading the sample holder into the chamber. First turn on the chamber view camera and monitor. Okay, we're now ready to turn on the camera, monitor, the switch back here, and of course the monitor itself. Then vent the specimen exchange chamber. To vent the specimen exchange chamber, simply hit the air button, and it will take a few seconds for it to get to atmosphere. Then grab the housing, not the rod. Bring it out until you hear the click. Unlock the rod. Grab the sample holder and feed the screw onto the holder. Right now there's about 20 turns, and you'll know when you hit the end stop. It won't turn anymore. There you go. So retract, lock the rod, again using your hand on the housing, not the rod, and then evacuate. To evacuate the specimen exchange chamber, hit evacuate. Starts pumping down. It'll take about 90 seconds to reach 2 Pascal, which is when you can transfer the sample holder into the chamber. This is the gate valve, which we open and close. Right now it's opening, and you can see the sample holder on the rod. We're now closing the gate valve. So this is actually the sample stage. The sample holder comes onto the stage. This is actually the EDX detector in its retracted 6th position. This is the coal finger with a hole cut into it so that the X-ray detector can be put into the chamber. So it's important to make sure that this is retracted. This is the lens, the objective lens for focusing the electron beam. So this is normal. So you can now load your sample. Once the specimen exchange chamber pressure is at 2 Pascal, you slightly unlock the exchange rod and hold it in position. You then open the manual valve and slowly push in the holder while looking at the monitor. When you get to the stage itself, just give it a little push and then you can unwind the exchange rod screw so that we can release the sample holder on the stage. This again will take about 20 turns in the opposite direction as we're unthreading. Once you think you are there, just slightly pull back to make sure you have disconnected. Look on the monitor again, and we're good to go. I'm now retracting this slowly. Now before you get to the end, close the manual valve. This is important. Before you lock. This is to protect this seal. Once you have your sample loaded, go ahead and swipe the Isaacs on. It'll go from red to green. This will allow you to turn on the high voltage because it is interlocked. When you're done, of course, you will then turn it off. Okay, we now turn the gun valve switch into the up position. This will allow us to turn on the high voltage. So select the voltage you need for your sample. In this case, 15 kV is okay. Turn on the high voltage. It will ask you to verify your sample size. So this determines how the stage moves, so make sure that you've got the right sample size as the default. And in this case, we do have 15 set here. If you need to change it, you just go into set and select whatever sample holder you're using. But we're using 15 today. So, okay. Turn the voltage on again. Hit OK. What's going to happen is the column gate valve will open, the high voltage light will come on, and then you will see along here the emission ramping up. So here we go. There's the emission ramping up. It takes a few moments, so be patient. Okay, so now we can close this. Make a note of the extraction voltage up here in the upper right corner. This 5.5, write that down in the logbook as the starting extraction voltage. First thing you should do is hit auto brightness and contrast, this button here. And the computer will automatically set the brightness and contrast levels. Okay, what you should also do is choose your mode. We're going to go in ultra resolution mode. We want to be 12mm working distance. Hit auto brightness and contrast again. Okay, then locate the area of interest on your sample. And to do that, we toggle between high and low mag mode. So I'm going to click on this. You now see LM, low mag. So this is our sample, which is a region of magnetic tape. If you need to move it at low mag, click on the mouse here. You get the stage hand, and just click and drag. Okay, so let's say that's the area of interest. We can now go back to high mag and verify working distance is 12. It is. Okay, why is not 12 there? Okay, 12. So now we can ramp up the magnification, and you begin to see a few things here that are kind of out of focus. So move something into the center of the screen, and I like to use the reduce raster, which is this icon here, and then adjust the coarse focus accordingly. Let's go back to full screen. This is frame average.
This is frame average 2, which is 32 frames. These positions are the slow scan positions. These are what you typically use when you're acquiring an image. But for now we're going to be in frame average mode, and I'm going to increase the magnification accordingly to the feature size. I'm going to increase the contrast a little, and again reduce raster, play around with the fine focus. And if you notice, we're seeing polarized direction. This is astigmatism. So what we should do at this point is stigmate as best as we can, first with the X to try to get a reasonable image, and then with the Y. And there we go. So now we are ready to start the alignment process for high resolution imaging. Okay, while you're using the tool, you may get the please flash warning sign, as you can see here in red. So if this happens when you're using the tool, you first need to turn off the high voltage. Then right click on the high voltage control panel, click on flashing, and then simply hit execute. But note in mind that the flashing will appear here, and then there will be a momentary flash current here. You need to write that flash current down in the log sheet. So here we go, I'm going to hit execute. And the flash current was 31.7 microamps. Write this down in the logbook. Now you can turn the high voltage back on and continue your imaging. I should add that typically you'll get the flash warning before you fire up the FESEM. At that point, of course, the high voltage is not on, and you can just simply go ahead and execute the flashing. And same procedure. Alright, so now we're back to imaging. We're going to do some high resolution imaging, and if you notice, we're in normal mode here. But before we go to ultra high resolution, I'd like to point out that we had flashed a few minutes ago, and the emission current that was initially 10 is now dropped to 6.5. So for the first hour this will happen, and so you just need to hit set, and it will reset to 10 microamps. There you go. So now we're going to go to column setup, and we will select ultra high resolution, and we now go through the focus and alignment procedure again. Whenever you change voltage or working distance, you have to do this. So we initially check the coarse focus, and remember the reduced raster. You can manually set the contrast by using these sliders. Check the stig. Try to get the best possible image. Okay. So now we're ready to check the alignment again. Yeah, the beam align should not have really changed much since we didn't change the voltage, and that looks good. Aperture align, we do have a little bit of rocking, and so if you remember, we use these alignment pots to reduce that so that it just goes in and out of focus like that. So remember, turn off the alignment, just quickly recheck the focus. And at this point you can actually go a little higher because we've got small features. And okay, check the stig. Alright,
So now we can just quickly recheck the aperture line, and it still looks good. Stiger line X, that looks good. Stiger line Y, that's fine. So now we're ready to capture an image. But since we're doing high resolution imaging, we're going to go to a shorter working distance. Right now we're focused at about 11.5, and the mechanical distance is 12 over here. The computer is telling us the minimum working distance is about 4.9. So I would select 6 millimeters at this point. And then hit go. Okay, so now we're out of focus. And you should change this to, say, 5.5, since we were focused at 11.5 before. Okay. Let me back off the magnification. Hit auto brightness and contrast again. And coarse focus to regain the image. Okay, we can go higher in magnification again. Let's go to 100,000. Reduce raster. Fine focus. And again we see astigmatism as we go through the focus. So we need to correct for that again. There we go. There's the Y correction, and there's the X correction. Okay, now one more thing we can do to improve the image resolution is in fact to lock the stage. So when I hit lock, you'll hear a clamp grab the stage, and then you will lose the ability to change the working distance and the tilt. So make sure this is the conditions you want before you lock the stage. So when I hit lock, you'll see these two things gray out. So these are now grayed out, and if you notice, that mechanical clamp causes the sample to go slightly out of focus. And so once again, we need to check the coarse focus. There we go. Let's go back higher in mag to 100,000. So, and if you notice, the stage drifts. So for about the first minute after you lock the stage, there is this mechanical drift. So don't worry about it. You can continue tweaking the focus and the stig. So while we're still drifting at this high mag, I should explain that these two positions are frame average. And these scan speeds are basically the conventional slow scan modes. So you can actually acquire these images in either mode, depending on the sample. So let's go back to frame average, just for getting our rough focus. And at this point, I'm just going to quickly verify we're still in the good alignment. And there we go, it went a little bit out of alignment, so we need to correct that so that it just goes in and out of focus. So now the sample is just going in and out of focus. Quickly check the stig alignments, everything looks good. So now we can tweak the focus one more time. Check the stig, make sure everything looks good. Let's reduce it down to 100,000. You can see what the image will look like in slow scan. It's a little too contrasty, so I would back off on the contrast and increase the brightness a little. maybe increase the contrast just a little. So we can now go to setup image, and in this panel you can select the capture speeds for either frames or slow scan. 80 seconds is a good number. It's a compromise between actual stage drift and the time it takes to acquire the image. So now we're in slow scan mode. You can now hit capture, and this is now going to capture an image. Yes, it's going to take 80 seconds. And if you notice, it's a little out of focus. And again, notice that the emission current is still dropping because we had flashed recently. If you don't like the image, you can hit cancel, which is what we're going to do now. And then we're going to go back to live. And what I'm going to do is set the current again. Back to 10 microamps emission over here. I'm going to go to 130,000. Get this thing focused properly. As you can see, we can see probably 10 nanometer particles here. The stig, I think, looks good. There you go. Now you can drop the mag to say 100,000 since you focus at a higher mag. And I'm actually going to reduce the scan speed to 40 for this acquisition. So we hit capture. So that was a frame average capture. And then over here you have the image. Let's go back to live. So let's click over to slow scan and do a slow scan, 40-second capture. So full scale is 500 nanometers, so each bar is 50 nanometers. So you can see these particles are very small. So this is the image we expect you to take when you take your test. Let's go back to live. Okay, to save the images, hit save. And then go to the image folder and find your folder on the desktop. Put your name into the comments. You can select TIFF, JPEG, or bitmap. JPEG is memory friendly. If you need the TIFF for publication quality, then save them as TIFFs. I'm just going to put this in as test, and it'll automatically number them. So they've both been saved, and to clear them, and you see saved, do all clear, and they're gone. Okay, once you're done with your imaging, we can release the stage and go back to default and everything. But before we go there, Notice the emission current has dropped, so remember you can reset that. And if you also notice, the beam monitor was flashing red and is now green. So if ever this flashes red, you hit adjust. And I'll just do that. Okay, so now I'm going to release the stage lock. So now these come back. Of course the sample goes out of focus, but we're not worried about this because we're going to go home. And if you look at the monitor, you will see that we are tilted and we're at working distance of 5.6. So when I hit go home, the stage will automatically default to the sample exchange position so that you can extract the sample. So I'm going to reduce this, then change any settings back to default, like we changed the image capture. Column setup needs to be normal. The working distance is 12, and I think that was about it. There wasn't any things we changed. Everything else is now defaulted. At this point you can turn off the high voltage, noting the extraction voltage of 5.1, which you will write in the logbook. So now we can turn off the voltage and then turn the gun valve to off. We're now ready to remove the sample holder from the chamber. So first we do is always unlock the rod. We can now open the manual gate valve, and we can now push this in smoothly. And now we need to screw it back on. It was about 20 turns, if I remember. You'll know when you hit the end stop, it won't turn anymore. Right now. Okay, so now hold the housing and give it a good pull, because we're pulling against the springs on the stage. So here we go. Retract nice and smoothly. Bring it close to the end. Hold it there. Close the manual valve. Now we can lock and vent. This will take a couple of seconds to get to air. And then we grab the housing. Open it up, let it click. Unlock the rod, grab the holder, unscrew it. Put it down. Remember, retract, lock. With the hand, close the housing and pump down. Once you've extracted the sample holder, you can now exit the software safely. Okay. Now we can remove the sample from the holder. In this case, the Hitachi standard goes back in the box here. Put that away. And you can simply put everything back into this nitrogen box as it is. And then just sign out the book with the timeout. Okay, now we can transfer the files using the FTP program FileZilla. You will need to request access to the Gateway PC through the ECEE IT folks, so make sure you get that done. So basically going to log in using your ASU Write. Students will use their ASU AD. I'm just demonstrating ASU Write for myself. And then connect. It'll ask for your password. And this is your regular ASU Write password. And then if you notice we're connected, and then basically each person gets to see their own folder, so they're protected.
So what I'm going to do now is find my folder on the desktop over here. There it is. I got these 3 images I want to transfer. So I'm going to select all and then basically just drag them over. And so they're now saved on the FESEM Gateway PC. So now we can exit. So when you get back to your office or wherever you are, you can then remotely log into the Gateway PC again and pull these files off. Once you've done that, then go back and delete the images you've saved on the desktop on your next visit. Typically I will wait 2 to 3 weeks to allow you to do the transfer and delete. If not, I will come in and delete the files, since they take up memory, which then affects the FESEM application software. In other words, it can crash. So be warned that you need to delete the files within 2 or 3 weeks after you've acquired them on the desktop. And before you leave the lab, turn on the fan and check that the vacuum in the specimen exchange chamber is at base pressure, which it is. It's in high.